Okay, welcome to Lesson 30. Our objective in Lesson 30, which is called Linear Systems in Three Variables, is I can solve systems in three variables algebraically by solving for one variable at a time. So let's get going here. Okay, so the first thing is to determine the value of x and y in the following systems of equations. So when we have systems of equations, I'm just going to write it bigger so you can see what I'm doing here. As we stack them, and then we can subtract one from the other. So the x's cancel out, and we have 3y minus y is 2y equals 4. So y equals 2. And you divide both sides by 2. Now I can plug back in to my initial equation. So I solve for one variable at a time. I solve for y. Then I get 2x. I'm just going to plug it into this equation. Plus y equals 3, 2x, and I said y equals 2. Subtract 2 from both sides. 2x equals 1, x equals 1/2. And if you wanted to, you could plug those values back into the other equation to make sure they work. Y equals 2. So 2 times 1/2 is 1, plus 6 equals 7. It works. Now let's do this one. So the coefficients in front of our variables don't match, so I need to get a matching coefficient. So what I'm going to do, I'm going to rewrite them just so they're kind of spread out a little more. I'm going to multiply my bottom expression or equation by 2. And as long as you multiply both sides by 2, it all works out. So now what I get is 5x minus 2y equals 4, and then I get negative 4x plus 2y equals 4, because you distribute the 2 to every term in here. Now I'm going to add these. So my y's will cancel out, and I get 5x plus negative 4x is x equals 8. So I just solved for the one variable. Now I'm going to plug it back in. Let's plug it into the first one. 5 times 8 minus 2y equals 4. 40 minus 2y equals 4. Subtract 40, whoops, got ahead of myself, from both sides, and you get negative 36 equals negative 2y. Divide both sides by 2, negative 2, and you get y equals 18. And if I were to plug it into my second equation, and I plugged in x equals 8, y equals 18, they would be, that would equal out. And one way we could write our answer, so we think of it as kind of a coordinate pair, x equals 8, y equals 18. Always go in alphabetical order with those. Okay, so now we have three equations, or three variables. And remember, the idea is we eliminate, or we solve for one variable at a time. That was in our objective. So I'm going to look at my equations, and I'm going to see where I have common coefficients. And if I look at the z's, they have coefficients of 1. So step 1 is to line up two of the three variable equations and eliminate one variable. So I'm going to have 2x plus 3y minus z equals 5. And then 4x minus y minus z equals negative 1. So I'm going to subtract this one. And I'm going to get negative 2x. Positive 3y minus a negative y is plus 4y. Negative z plus z is 0. 5 minus negative 1 is 5 plus 1, which is 6. So I've got that two-variable equation now. Then it says to line up two more three-variable equations to eliminate the same variable in step 1. So I eliminated z, so now I have to eliminate z again. So there will be times where we have to change some of our coefficients to do this, but not this time. Okay, if I look at how they are, the signs are opposite, so I can just add 4x plus x equals 5x. Negative y plus 4y is positive 3y. Negative 1 plus 12 is 11. And I eliminated my z's. So now, line up two of your two variable equations. Okay. And 5x plus 3y equals 11. It's a plus. And it says get matching coefficients for one variable. So let's get matching coefficients for x. So I'm going to have to multiply this by negative 5, and this is all multiplied, I'm sorry, not by negative 5, by positive 5. And this I'm going to multiply by negative 2. Okay, or if I did positive 2, that would work as well. Okay, in fact, I'm just going to do positive 2. It makes it easier. So now this equation becomes, I'm going to distribute the 5 to everything. So this becomes negative 10x plus 20y equals 30. And this one I'm just going to multiply by 2, so I get positive 10x. So those, when I add these equations, will cancel out. Plus 6y equals 22. So when I add one to the other, negative 10x plus 10x is 0. 20 plus 6y is 26y equals 52. So that means if I divide both sides by 26, y equals 2. All of this should be in this box over here. Okay. So remember, we're solving these by figuring out one variable at a time. So now I know y equals 2. So I'm going to plug the value I found in step 3 into one of my two variable equations. So let's plug it into the 5x plus 3y equals 11 equation. So 5x plus 3 times 2 equals 11. So 5x plus 6 equals 11. So I'm going to subtract 6 from both sides. 5x equals 5. X equals 1. Okay, so far I have 1 for x, 2 for y. Now plug the values you found in steps 3 and 4 into one of the three variable equations. So I'll just pick the first one, 2x plus 3y minus z equals 5. So x equals 1, so I have 2 times 1 plus 3 times 2 minus z equals 5. Oops. So I have 2 plus 6 minus z equals 5. 8 minus z equals 5. Well, I know that 8 minus 3 equals 5, so z equals 3. Okay, I could subtract 8 from both sides and then divide by negative 1, and I would also get z equals 3. So my solution is 1, 2, 3. That's my x value, my y value, and my z value. Okay. This one's a little bit easier because you can actually get rid of two variables at once right here. So let's stack those two equations and it'll give us our r value. S plus u equals 4. R minus S minus U equals 2. If I add that, I get R. Those go away, equals 6. Okay, so now I have one variable. And then what I can do with that is I can start substituting stuff in. So let's go to this equation. R plus 2S minus U equals 8. 6 plus 2s minus u equals 8. So now I have a two-variable equation, and I have also another two-variable equation, s plus u equals 4. I'm going to add that because I have a negative u on top. So 2s plus s, don't forget the 6, 6 plus 3s. Okay. My u's cancel out, equals 12. I'm going to subtract 6 from both sides. So I get 3s equals 6. S equals 2. 3 times 2 is 6. So I know my r, I know my s. I'm finding these one thing at a time. Okay, and now I can just say, well, I know that I have this equation, s plus u equals 4. So 2 plus u equals 4, u equals 2. So if I put them in the form of r, s, u, it's going to be 6, 2, 2. R equals 6, s equals 2, u equals 2. Those are their values. We're going to stop here for this video.